Welcome to Eureka Math. I'm Mr. Schenkel. I'm going to be helping you today with fraction division models. This is part one, and we're going to be dealing with whole numbers divided by fractions. Let's get started. The type of problem that we're talking about is a whole number like 5 divided by a fraction, in this case 1/3. And we need to make a model to fit this situation so that we can find the answer without knowing the algorithm. So we'll use the algorithm at the end just to check it to see if our answer is right. But let's start by creating a model. The first thing I'm going to do is, on these type of problems, is model the whole number, so the 5. So I'm gonna make myself 5 boxes here, and let me try the. Oh, that's not what I wanted to do. Here we go. Let me try this. This is a new tool of mine that I'm trying. I'm going to try to copy that and then paste it. Oh, look at this. There we go. There's 2. And then we're going to paste another one. There's 3. So basically I'm just making 5 of the same size box. That's 4. And one more gives me 5. All right, so there's my 5 boxes. That represents the whole number 5. Now I'm going to take the box, each box, and I'm going to split it into whatever my denominator is. In this case, it's a 3. So I'm going to split my boxes into equal thirds. So it looks like this. There's 3. Oh, that's a bad one. Let's try that again. Better. Horrible. For some reason it jumped over there to the half. Okay, that's fair. Decent. That's okay. Not good. Try again. There we go. And one more. Okay, so there's my 5 whole boxes. I split them into thirds, and then I'm going to just make myself groups of 1. Well, groups of 1 is easy. I just have to count them. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 9, 9. Good. 10, 11, 12, 13, 14. There's 15 of these groups of 1/3, so my answer is 15. And let's use the algorithm. We know that we can't divide by fractions, so we will multiply by reciprocal, and 5 times 3 is 15, so we know that the model worked. Okay, let's try another one. This time we have a whole number of 3, and we're going to split it into fifths this time. So I'm going to put my same boxes out here. There's 1, and there's 2. Let's put it right there. And one more. There's 3. Okay, so that models my whole number 3. And then I'm going to split it into whatever my denominator happens to be. In this case, my denominator is a 5. So I'm going to split these boxes into 5 equal pieces. Wow. Let's try again. It wants to jump there. There's 1. No. Here's, wow. Okay. Maybe I won't be able to use this tool. Yeah, maybe not. Okay, so what I'm going to do is I'm going to back up. I'm just going to draw 1, 2, 3. There's 5 equal pieces. There's 5 equal pieces. And there's 5 equal pieces. Now, my next job is to group them into groups of 2. So I can see that, that here's a group of 2. So that's 1. Here's another group of 2 right here. So that's 2. Doesn't that look like Squidward's eyes a little bit? I don't know why that just struck me. Okay, here's 3. there's one there and one in the second box, so that's another group of 2. So there's 3. Here's the 4th. Here's the 5th. So that's 4. That's 5. Here's another group of 2. That's 6. Here's another group of 2. That's 7. And this would be my 8th group of 2, but I'm missing one. So I only have 1 out of 2 here. So my answer is 7.5. 7.5. And if we use the algorithm, let's see what we get. 3 times the reciprocal, I get 15 halves, and 2 goes into 15 7 times with 1 left over. So I know my answer is the same. Okay, looking good. Let's try another one. This time I've got 2 groups. So I'm going to start with 2 boxes. There's one. And here's another one. 2 boxes. And now I'm going to split it into each of those into groups of 7. This is going to be a little tougher. 1, 2, 3, 4, 5, 6, and 7. So there's 1. 1, 2, 3, 4, 5, 6, and 7. There's the second one, splitting into groups of 7. So I used whatever my denominator is. That's what I split it into. And then again, I want groups of 2. So I'm gonna highlight these this time. Let me get a different color and see if we can highlight these nicely. That'll work. So here's 2 right there. So that's 1. And I don't know, maybe this won't work. Oops, let me go a little different color here. That's good. Here's another 2. So that's 2 of them. And let's see a different color. There we go. Here's another group of 2. There we go. And let's see another one, another color. All right. Here's another group of 2 right there. And let's see, let's change again. Oops. Okay, here's an ugly color. There's 1, there's 2, and I can keep going. Need another one. And so let's see, maybe this one. There's 1, and there's 2. And then if I've got one more color here, maybe I can get to. Yeah, that will work. There's 1 and 2. So now let's count them up. We've got 1, 2, 3. The greens there are 4, 5, 6, 7. So it looks like my answer is 7. There's nothing left over this time, so my answer is 7. Let's check the algorithm. 2 times the reciprocal. Well, I can see already that the 2's cancel, so it's true. My answer is 7. All right, one more. Looks like we'll be able to make it. 4 groups this time, so I'm going to model my whole number again. There's 2, and here's 3. It's pretty good. And one more. There's 4. Okay, so that models my whole number. And then I'm going to split them into groups of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And last one. There we go. Pretty close. And then I'm just going to find 4. So I'm going to put 4 together. There's 4. And let's see. Here's 1, 2, 3, and that's 4. So that's 2 so far. Here's 1, 2, 3, and 4. And here's 1, 2, 3, and 1 more is 4. And then 4 more. Oh, nice. We've got 4 more. So my answer is 1, 2, 3, 4. Looks like 5 total groups. And that's my answer. Hope that helped. See you again next time.